Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video we're going to look at using the robo hat that I designed a while back. Okay, so to make it easier to see what I'm doing, I've actually removed the servo output board so that we can see just the pins, and in this video we're going to look at the PCF 8574. Now that is this chip over here on the board. It is a simple 8-bit or 8-channel I/O expander. The way it works is very, very simple in as much as it has one register for reading the state of the pins that are presented on the outputs or the inputs, as the case may be, and a register to configure the output driver. So with these, they can source, when they're set to logic high, 100 microamps. So it's not very much. If you try and put more load on than 100 microamps to a pin that is set to high, it will pull that pin down to low. And that's how we use it as an input. We set the output to high and we literally put our buttons and sensors to bring that line down to ground. And when that happens, we can read that as an input. For an output, it's got a very strong pull down. So when you energize the pull down, it can sink as much as 20 milliamp, I think it is from memory. And that allows us to drive things like LEDs. So what I've wired up here is from the VCC, or 3.3 volt, which is the upper pin in this dual row header, going through a resistor, through an LED, and then back to pin 0 or output 0. And then I've created this simple code in Python. So I'm using SMBus. I could have used SMBus 2, and I probably will change it to SMBus 2 because it's the latest version. And we create that as I2C bus. I've also listed the address, the I2C address, as 0x20, and that's where this chip is located when you look at the I2C address bus. I have previously run an I2C detect, and that's it there. So all these other finds are actually all the other chips on the boards. So coming back to our program, we're going to set all of our outputs high to start with. So we'll write to the 1 byte to the I2C bus at address 0x20, and we're going to write all ones. So 0xFF. And then we'll go into our loop, and all we're going to do is wait 1 second, and then we're going to write 0xFE, which will turn off just the first bit. I could have expressed that differently. In fact, I will do that for this example. We can do this in binary. So B 1, 2, 3, 4, 5, 6, 7, 8. So we can see that last bit is a 0, and for this one, binary 1, 2, 3, 4, 5, 6, 7, 8. And if we run that, you'll see that the LED is now flashing as it. And this thing also prints to the screen down the bottom here the current state of on or off. So we're actually turning the bit on to turn it off, which sounds counterintuitive, but we are turning on a drive to ground, allowing current to flow. We can actually use that to our advantage, and I do that with the PCF 8574 4x4 keyboard, where I actually use all 4 I/O and use that to drive a little 8x8 matrix keyboard. Sorry, 4x4 matrix keyboard, which gives us a total of 16 buttons. And in this program we cycle through and we can work out what buttons are pushed. Okay, so that'll do for this video. To see the next video in this series, don't forget to click on like, subscribe and ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account, and you can join my VIP patron Go Lucky, my all access patron Jeff Jerd, and my builder patrons Al Morales 45, Andrew Cardone and Airgar69 and Stefan Paps in supporting the channel. I also have YouTube membership, so if you'd like to, you can join through that method as well and get your name on this list. If you have any questions, feel free to leave a comment below or drop into the Discord and we can discuss it more in there. And we'll see you in the next video.